right, hi everyone. Welcome to week 2 of DAX 601. This week we'll cover Tidyverse, data transformation, data tidying, and data import. So video 1 will be Tidyverse and data transformation. Video 2 will be data tidying, and then video 3 will be data import and an example that pulls all of these things together. Our agenda, again, as I said, a more detailed breakdown you can find right in the beginning of the slides. So I'm going to go through my slides and then run to our studio so that we can walk through examples there. So let's talk about the Tidyverse. The Tidyverse is essentially the core of this class. Our textbook is rooted in the Tidyverse, and the different packages that I ask you to read about each week, those are all going to be Tidyverse packages. So Tidyverse just pulls all of this functionality together. It's a collection of individual R packages. You can look up tidyverse.org and you can see all of these packages more in depth. You'll also see that the textbook that this website references is the one that we use for the majority of our class. So Tidyverse is just a collection of functions that make data analysis easier, especially when it comes to data import, transformation, visualization. So the Tidyverse. When we think about the Tidyverse, that's built on data that is tidy. And tidy, we mean the following: that every variable is a column and that each column is a variable. Each observation is a row and each row is an observation. And finally, each value is a cell and each cell is a single value. So this means that each of these columns only represents a single thing. So country is a distinct variable from year, is a distinct variable from cases, and so forth. There's nothing crammed together representing two things in the same column. That each row only represents one set of observations, so it might be each row represents Afghanistan in the year 1999, like this example, or maybe each row represents my survey responses, so my survey responses are only in one row. And then each of our cells only has one value, so it doesn't have two or more values smashed together. It only means the cases of Afghanistan, for example. But our data typically does not come tidy. That's most of the data sets we encounter is not going to follow this type of format. So to get it into the tidy format, we have to do data transformation. This is rooted in the dplyr package. So I asked you to read that for this week. We're going to go over all of these different functions. Dplyr is a grammar of data manipulation, and mutate, select, filter, summarize, and arrange are some verbs that are helpful for us in our data transformation. The basics of these functions: anytime you encounter a function, be it mutate, select, whatever, or you can think of that as a verb, you're doing something to the data, you list the function name, and then the first argument is going to be the data frame. After that, you tell it what columns it needs to operate on using the variable names, so the column names, and the output is always going to be a new data frame. So that's just something to think about as you're doing anything with the dplyr package. We also often use the pipe. You'll see me using this frequently in my code, and the pipe just makes it incredibly clear what verbs we're using, or what functions, what things we are doing to our data. So we start in this example, we say, okay, open flights and then. I always read the pipe as then. So the vertical line with greater than, that's the pipe. I read it as then. It's just this, then this, then this. You can combine multiple functions together, so that way you don't have to do flights and then filter, and then flights and then mutate, flights and then. You just do it all in one section. And you always want to enter a new line after you use the pipe. So once you have the pipe, the next verb needs to be on the subsequent line. Something to note is that if you're using the pipe, you do not have to designate the data frame first in the function. That's another value of the pipe, is we say open flights and then filter, and it already knows what data frame we're using this on. So if you're doing a standalone action, then you have to specify the data frame. But if you're using the pipe and you've already specified, okay, I want to work on the flights data, R is going to know what to do, and your first argument is just going to be the columns that you want to work with. Piping's really important and really, really valuable. I like to recommend that, especially when you're first starting out, that you comment each line that describes the exact step that you're trying to take. So dplyr, we can work with our rows and our columns. To work with our rows, we have 3 different functions. Filter is going to change which rows are present without changing their order. So this is how you can subset, and you say, okay, I only want the rows that have this value. And to designate the value, that's where you're going to use logical operators. So less than, equal to, equals to, not equals to, that we talked about in week 1. You have to use equals equals, or I read that as equivalent to, rather than just the single equals. If you're trying to do a logical operator or a logical operation in filter or anything, you always have to have that double equal sign. Arrange is going to change the order of the rows, but it's not going to remove which ones. So let's say you want to arrange a numerical value by greatest to least, you can use arrange for that, but it doesn't remove anything. And then distinct is going to find all of the unique rows in the data set. So let's say we have rows with my name and 2 other people's names, but there's 5 rows in our data frame. It's going to pull out the 3 unique names that are represented in the data set. It's not each row, it's what is present in these rows. So if my name comes up twice, it's only going to count that once and say, okay, Larry's in here twice, someone else is in here twice, whatever. Columns. You can create new columns or variables based on existing columns. You do this with mutate. You can select which columns are present in your data frame. Let's say you have 15 columns, but only 5 of them matter. You can select so that there's just those 5. Rename changes column names. Often our data sets don't come with clean names. They'll come with spaces in the name or numbers in the name or names that just don't make sense. This is a way to change it so that it makes sense for your analysis. When you use rename, note that you always have to use new name equals old name. So whatever you want to name it goes first, followed by what it currently is. And then finally, relocate changes the positions of columns. So if you've mutated a new column, you can move it so it's right up front so you can see it. Or if you want to group all of the date columns together, for example, you can do that with relocate. We also often group our data. So to do this, we use group by. What this does is it breaks down a column into its categorical groups. So something like month or gender or education level. There's only, let's say, 3 education levels in our data set: bachelor's, master's, and PhD. It's going to report the values based on those groups. So let's say we have 15 rows, that each have, master's, 15 doctoral rows, 15 bachelor rows. Group by is going to allow us to get a single value across all the bachelors, across all of the masters, across all of the PhDs. Summarize, you've already worked with this in tutorial 2. Summarize creates a new data frame. When you're using summarize, it's important to use descriptive column names. So mean equals the mean of the column, and that way you know exactly what value you're referring to when you get that outputted data frame. And then finally, slice allows you to extract specific rows from each grouping. So let's say I group by education level, and then I calculate the mean earnings. I only want to see the top earning from each group. Slice by 1 allows me to see, okay, there's the top. So let's go to RStudio with some examples. Like I said, the next video will cover data tidying, but I have some code for you just to visualize and think through these examples. As you can see, I always like to start and check, okay, what is my working directory? It's my main DAX 601 Summer Session 2 folder. And then at the very top, I have the libraries that we will need for this script. So we will need Tidyverse. You're going to need Tidyverse for everything you do in this course. And then I'm also going to be pulling from the NYC Flights 13 data just to give some examples. So the way these scripts are organized, I have the sections that I'll go over in each video, and then this entire script is under week 2. So let's start. If you don't have NYC Flights, what you can do installed as a package, you can just uncomment that line. I like to start out with looking at my data to see what's there. I pulled in my NYC flights package, but I don't know what's in flights. What I can do is just use question mark and look over here in the bottom right quadrant. You'll see me do this a lot in our example scripts just to get you in the habit of looking up the functions or the data that you're working with. So flights records on-time data for all flights that departed New York City airports in 2013. And to get this data into my working environment, I just use data flights. It pulls up here as a promise, and then I can view flights, and it pops up here, and now it's in my global environment so I can access this data. So let's do a little bit of transformation based on rows. I look here, I see, great, I've got 19 different variables. I have 336,776 observations, so that's the amount of rows I have. I maybe don't need all of this data. Maybe I just want to select and subset to a smaller data frame. What I can do is I can filter the rows, and let's say I want to check the flights that are delayed more than 1 hour. I just want to see maybe the airlines that I want to avoid. So I can filter based on the specific column. So departure delay is the column that I'm interested in, and I want to subset only the ones that are delayed for more than 60 minutes. So here we can see in my console, let me move this up a little bit so you can see it a little bit better. Here we can see that subsetted data frame that went from 336,000 to now down to 26,000. Let's say I want to see the flights that departed on my birthday, which is July 18th. I can filter to month is equivalent to 7 and day is equivalent to 18. So I can have more than one logical operator in one filter command. Here, we can see that there's only 1,000 flights that departed on my birthday in 2015. And let's say I want to save that. So rather than just seeing it in the console, I want it to be in my working environment so that way I can manipulate it further. What I do here is I assign this to a new data frame. So I say, okay, I want it to be flights Larry birthday, because that's descriptive. I open flights, then I filter just like what I did above. So now when I run this line, flights Larry's birthday, in here we have all the same columns, but far fewer rows. Or maybe I just want to know the flights from the summer months. Same thing, I'm going to say flights summer, open flights, then I can use the in logical operator that I only want the months of 7, 8, and 9. So our months are recorded as numbers, so I say, okay, 7, 8, and 9, June, July. Actually, I messed this up. That would be July, August, September, so maybe late summer. I can also arrange the data in ascending or descending order. So let's say I want to arrange so that I see the longest flight delay. I'll pull my birthday example back. I can use arrange descending on the departure delay column, and we can see here that the longest flight delay on my birthday was over 6 hours. It was 396 minutes. Let's say I want to know, okay, how many carriers are represented in this data? What are the different options? Here's where I would use ndistinct. And what I do is I specify just one column. I don't want to do the pipe, I just want to do one thing. So I say, okay, flights, I use this money sign operator. I just want to pull out the carrier column. So ndistinct, there's 16 different carriers in this flights data. I could do the exact same thing with summarize. Summarize I think is nice again because it creates a new data frame, and if I wanted to have multiple operations I could do that, but this is just showing you that summarize and the money sign can do similar things. I could use summarize, saying open flights, then summarize, unique carriers. I've created a column name that makes sense and distinct of carrier, and I get the same answer of 16. Let's say I want to mess around with my columns. This is where I'll use mutate. So in the previous example, when I saw that there were 396 minutes, I pulled out my calculator because I don't know how many hours that is in the top of my head. But R is a calculator, and so I can actually do that with code rather than pulling out a different device. So what I do here is I'm going to create a new data frame. I'm going to name it hour because that's the column that I add, right? And I do this, in my scripts for these examples, I hard code a lot of the middle steps just so that you can open up the in-between data frames and see for yourself how it changes when you run through the script. So I'm calling this hour because that's what I'm adding in. Open flights, I use the pipe for then. I'm going to use mutate, and this is my new column, departure delay by hour. And all I'm doing is just dividing those minutes by 60, and I'm moving this after departure delay just so that way it's right around the column that it references. So here, I created that. Let's open it up. We see up in here, it started with 19 variables, now I have 20 variables, so I was successful in adding a new one. Right here is departure delay by minute, here it is in hours. So that way, I don't have to do the mental math because I'm not good at mental math. I can also arrange within that hour variable. So here it pops up, departure delay by hour. The longest delay in 2013 was 21.7 hours. So 21, nearly 22 hours in 2013. I can also select only the columns that I want. So there's 20 different variables here. Maybe I don't want all of them. What I can do is flights, then select year, month, and day, and that's just going to show me those columns there. If I want to save it, again, I name it first, and now it's up here. I can easily pull it in to my environment. Let's say I, for some reason, want every column but the ones that designate the time. You can do the same thing, but just add this exclamation point. So the exclamation mark says not. I want everything but year to day. So here, flights, no date, no month, day, year columns. Or let's say I don't want any of the columns that have dep in them, any of the departure columns. I can select everything that does not contain this string value. So flights, no dep. Here we go. Now there's no columns that have that dep string in them. So departure time, departure hour. Rename will rename your column. Like I said, oftentimes the columns that we read in don't make a lot of sense because often the data that is out in the wild, it's not necessarily created for a tidyverse analysis. It's created for easy input or easy visual examination. So we can rename the distance column, for example, to distance in miles. So it's a reminder to us, okay, this is in miles as my unit. So here, flights rename, distance in miles is my new name, and then distance was the old one. Flights rename, over here, distance in miles. I've changed that name. And again, you can relocate those variables around. Rename, relocate is going to move distance in mile all the way to the very front. Grouping. So you'll see grouping a lot. Grouping is really important. Here, again, we're creating a new data frame, we're piping, then we're grouping by our origin variable. So that's the origin airport. We're going to use summarize to calculate the average hour delay. You see that I have a descriptive column name, and then we're counting, one that calculates the mean and one that just counts. So here, our output, you can see the mean of the average delay, and then the number of flights that come from each origin flight. So there's 120,000 from EWR. We can group by multiple columns. So it doesn't have to just be origin, it can also be destination. And we can use calculations with these combinations. So let's use flights departure delay by hour, group by origin and destination, summarize the mean delay, and then arrange in descending order. So I want to know who has the highest hour delay, what origin and destination combo. Here we see here that from EWR to TYS has an average delay of 0.697 hours. And again, slice will allow you to extract specific rows from each group. So here, I open up, again, flights departure delay by hour. I'm grouping by origin. I'm slicing the top hour the hourly or delay, and then I'm relocating that to the beginning. So here I can see that the longest departure delay from this EWR airport is 18.8 hours. From JFK is 21.7 hours, and from LGA is 15.2. So that's a little bit on data transformation, and our next video will go over lines 126 and beyond on data tidying.